Okay, so it's recording. So just to recap quickly, today we will be learning about Laplace transform or derivatives. So previously we have used Laplace transform on the function y or ft to get it in the frequency domain, which is fs. And today when we learn that when we transform derivatives, which is f prime t or dy dt, the result is sfs minus fo. Fo here means the value of the function y or f when t is 0 or f0. And the same for second order derivative. When we do the Laplace transform of that, we have it as s squared fs minus sfo minus f prime o. So now f prime o here means f prime, the value of f prime when t is 0 equals to 0. Okay, you can see in the books or the John Bird books if you want to see how they derive this. I'm sure in other books also have. Okay, but we don't have to show that right now. Okay, so now that we have learned how to transform Laplace transform derivatives, we can finally use it to solve differential equations. Okay. Okay, so let's look at the first example. The first example, we have this problem. Solve f prime prime t plus 4 f prime t plus 4 ft equals to 42 te minus 2t. Given f naught is 0 and f prime naught is 0. Okay. So immediately when you look at this, you see that the first step is step 1 is to apply Laplace transform to both sides of the equation. That means you need to do Laplace transform of f prime prime t plus 4 Laplace transform of f prime t plus 4 Laplace transform of ft equals to Laplace transform of te minus 2t. Minus 2t. Okay. So that's the first step. And then to get the values on the left hand side, you just need to replace it with the equations we have outlined here. So this one and this one, 1 and 2. So you replace this one also actually. You need to replace so there's 1, 2, 3. So all of these 3 you need to replace and put into the equation on the left hand side. Okay, so that will give you, and the one on the right hand side, you need to use the rules that we have learned before. Like this one, this can be either a first shift one, or it can be, remember the one that we did before with the longer one that you have to use the minus 1 squared, minus 1 to the power of n d over d s. Remember that one? So in this time we will use the first shift because it's easier. So basically we write it back. So this becomes s squared. Yep. Okay, s squared fs minus sfo minus f prime o plus 4, and then in here we have sfs minus fo plus 4 fs equals to 42. So this one, if you remember, I basically I'm rearranging this. 42 e minus 2tt, because it's easier if we do it using the first shift. Okay, I'll leave that there first. So we have, this is where the initial condition is very important. If it's 0 like here, then your work is much easier, since you can just cancel this straight away, because these are all 0 values. That will leave you with s squared fs plus 4s fs plus 4 fs equals to 42. Okay, so this one, remember, if you don't, since we're using the first shift theorem, if we are, the usual answer fs is 1 over s squared, but because we are shifting it with e minus 2t, so this one becomes 1 over s plus 2 squared. Okay, so this is the first shift theorem. You have to look that back up. Okay, so from here you extract the fs, factorize the fs, you are left with s squared plus 4s plus 4 equals to 42 over s plus 2 squared. And then this, actually you can factorize some more, becoming s plus 2 squared equals to 42 over s plus 2 squared. That means your fs is 42 over s plus 2 to the power of 4. Okay, so we have now managed to find the problem in terms of Laplace. Okay, so we give the given problem to us is in the time domain. Now that we have managed to transform it into the frequency domain, or fs, okay, using Laplace transform. So now we need to solve this to get the solution. Okay, so I don't think I want to draw it again, but remember that I'll just draw quickly. So we have the problem before in time domain. Okay, then we transform into the frequency domain. Then we solve it, and we have it in the solution in the frequency domain. And then we will inverse Laplace to get the solution in time domain. So right now we are here. Okay, next we will solve it. And to solve it means we will do inverse Laplace actually. Okay? We will solve it by doing inverse Laplace transform to get the solution. So if you look at this problem, fs. Sorry. Okay. So if you look at the fs, it looks like, if you remember the table for Laplace transform, it looks like t to the power of n, where this is the general answer. Okay, because you want to use the inverse round, right? So when you look at this, you can see that the power here is 4, which means n plus 1 is 4, therefore n must be 3. So you have to break this down into a form where you can directly inverse Laplace. That means you need to bring the 7 out, and then you have it of 6 here. It's 3 is because this is actually 3 factorial. Okay, so 3 factorial s plus 2 over 4. And again, using the rule of this one and also the first shift rule, we can say that you can directly do the inverse Laplace and you will get n is 3, right? So you have t 3 and then you shift it by 2, so it's e minus 2. Okay, so basically from this 42 we divide it into 6 and 7. Why? Because we need n to be 3. 3 factorial is 6, so we bring out the 7. Okay, and then you can directly do the inverse Laplace using this value, but you must also see, because this is not ordinary s, this is s plus 2, which means there is a phase shift of 2. That's why the final answer is t cubed with a phase shift of 2 minus 2 and also multiply with the 7 that you brought outside just now. Okay, so you can see this is how you solve a differential equation using Laplace transform. We went from having the problem in ft, changing it to fs using algebra basically, and then we got the solution here by using the inverse Laplace. So any questions about this question? Okay. So we have a few. Today we'll just be doing some examples about this. But the thing is, in the next few examples, I do it both ways. In that, I show you how to solve it using what we learned before, which is using calculus methods, and then we will do the same question using Laplace methods, and then we will see if the answer is the same. Okay, it should be the same. So we'll start with this one. So we'll start with this one, f prime t minus 2 ft equals to 4. Okay, so this is just a first order derivative. Should be quite straightforward, right? So first we look at how we can use this using calculus. Okay, if you remember, this is a linear differential equation, so which means that we can use the IF method. Okay, so first we identify what is P. P is minus 2, Q is 4, and IF is equals to E dt. So E minus 2t. Okay, and then the solution using the magical equation is YIF equals to integration of QIF dt. Y dot E minus 2t is equals to integration of 4 E minus 2t. This will give you 4 over minus 2 E minus 2t plus c. This will equal to negative 2 E minus 2t plus c. Okay. Then you bring down, put the y on one side. We'll have E minus 2 plus c E minus 2t. no, E2t, sorry. Okay, I forgot this part. Okay, so it is given here when t is equals to 0 of f0 is basically 1. Okay, that means now that you have the pretty much the final one, you need to find the value of c by putting the initial value. So when t is equals to 0, y, oh sorry, this one should be ft. I don't want you to get confused. Okay. So we have here 1 equals to negative 2 plus c e to the power 0 is 1. So c is equals to 3. That means we go back to this one. Ft is equals to 3e to t minus 2. Okay, so that is the final answer. So this is using the calculus method that we learned before, using the IF method. Now we will redo that using Laplace transform and check the answer. So the same question, f prime t minus 2ft equals to 4. Okay, so you apply Laplace to both sides. Laplace transform of f prime t minus 2 Laplace transform of ft equals Laplace transform of 4. So this one you get SFS minus FO minus 2FS minus 4 over S. So F0 just now is 1, right? So we have it SFS minus 2FS minus 1 equals to 4 over S. So we can factorize the Fs as S minus 2, and we can bring the 1 on this side. So we can put that as 4 plus S over S. That means you have your Fs equals to 4 plus S, S minus 2. Okay. So from here, like before, like in the previous week, we see that we need to use partial fractions. Otherwise, we cannot do the inverse Laplace. Okay. So, but today I will show you a way to do a shortcut of Laplace of partial fractions. But depending on the situation, okay, in this situation you can use it because there's no repetition of roots. And somebody want to join? I don't have any indicator that anybody wants to join. Try them to ask. Try them to try again because I don't have anything to click on my side. Okay. So anyway, from here we use partial fractions. So we have A with S and B with S minus 2, right? So what we're gonna do is it's called the partial fractions. It's called the cover up method. Okay, you can look this up. It will make your life easier, especially for the more difficult partial fractions. So in the cover up method, basically you somebody. Okay. So basically what you do is it's called cover up because you need to cover up or enclose one part of the fraction with your hand and with your mind also. Okay. So for this instance, we want to find a, right? So to find a, we set the s value as the value that would set the denominator to 0. So in this case, s is 0. So when we want to find a, we set it like, so what we're doing is we cover up method means the bottom, the s at the denominator, we close it with our finger. So basically you disregard the single s here on the outside. Okay. So this is what you close it with your finger. So you are seeing this only. And now you set the s value as 0. So 4 plus 0 and 0 minus 2. So the answer is minus 2. Okay, if you do the long way, you'll find that the answer is the same. And now for b, we see that b is over s minus 2. So if we change s to 2, it will become b over 0 again. So that is what we set. So s will be equals to 2. Okay, next, take the whole equation. Okay, we only take the s at the bottom, at the denominator, because we cover up the s minus 2. That's what they call cover up method. So now we have 4 plus 2 over 2, which is 6 over 2, which is 3. Okay, so that means you can rewrite that equation just now. 4 plus s minus 2 is equals to minus 2 over s n plus 3 s minus 2. So to find the solution, we need to find, to find the solution, we need to do the inverse Laplace transform of negative 2 over s and the inverse Laplace transform of 3 over s minus 2. So this one is from the table, you can do it directly. You get negative 2 because it's just a constant, and this one you'll get this one there's a shift there, you get 3e to t. Okay, so you compare this with the one that we found through calculus just now. It's the same, okay, but I just rearrange differently, so I'll just rearrange that. Equals to 3e to t minus 2. Same as the answer from when we use the IF method. Here, 3e to t minus 2. So it depends. In this context, it looks like more or less it's you can't really say that Laplace transform is easier. The steps is a bit longer. Okay, but it really depends on the kind of question. Okay, so but what this managed to show is that you can use both methods to solve differential equations. So any question about question example, this example 2? Hello?
No, doctor.
No, okay. Okay, so this next one I would like you to try first, because otherwise I don't think you'll be learning a lot if you just watch me. So you do this one first. I'll give you 10 minutes to do. I want you to use both methods, okay? I want you to use both methods so that it's good practice for you in either one, for calculus and for Laplace transform. And I think it will help your understanding also if you know how to do both ways. So example 2 is f prime t plus 2ft equals to 10e3t. And then given f naught is 6. Okay, so I'll check back with you in 10 minutes. Please try, yeah? Use both calculus and Laplace methods to solve. how's it going, guys? Can you do it? So I guess you need a bit more time. Okay, you continue. Okay, continue doing, and I will also do. So we'll start with the calculus side. Okay, similar to the first example just now, this is a linear differential equation, which means we can use the same IF method. Okay, we identified P as 2 and Q as 10 E3T. So the integrating factor is integration of P dt, and you get E to T. Then we use the equation. Equation Q just now is 10. IF is E to T. You can bring out the 10. This one you add up to be 5T. And then you have 10 E5T over 5 plus C. That is actually 2E5T plus C. And so your Y is equals to 2E5T minus 2T plus C E minus 2T. And you get 2E3T plus CE minus 2T. Okay, so here's where we use the information, which is F0 is equals to 6. So this is 6 when T is 0. E to the power 0 is 1. E to the power 0 is 1. So you get 2 plus C. So C is 6 minus 2 equals to 4. So put that in the original equation here. Y is 2E3T plus 4E minus 2T. So that's the answer when you use the calculus method. Now let's try that in Laplace. Oh, don't forget to sign attendance. It's on Putra Blast. Okay, so when you use Laplace transform, you apply Laplace to both sides of the equation. Then E3T. Then E3T. Okay. So here we have SFS minus FO plus 2FS equals to 10 over S minus 3. Then F0 is 6, but you can first factorize the Fs into S plus 2. F0 is 6, and 10 over S minus 3. So now you have Fs, S plus 2 equals to 10 over s minus 3 plus 6. Okay, you times 6s minus 3 to get it the same denominator. Then plus 6s minus 18 over s minus 3. So that will give you 6s minus 8 over s minus 3. And that is, if you want fs, you can bring down the s plus 2. So you will have s plus 2, s minus 3. Okay, so this is your fs, which later, once you do the inverse Laplace, you can get the solution in time domain. Okay, so breaking it down, we can use partial fractions. We can also use the cover-up method. Okay, so we have a over s plus 2 plus b over s minus 3. So to find a, we set s equals to minus 2. So a is equals to, you cover up the s plus 2, right? So this becomes minus 6 minus 2 minus 8 s minus 3, which is minus 2 minus 3. This will give you negative 12, negative 8 over negative 5, negative 20 over negative 5, which is 4. And then for b, similarly, to find b, we set s is equals to 3. So b is equals to 6, 3 minus 8. And then we have s plus 2. So we have 3 s plus 2. So we cover this one. 3 plus 2, which is 5. So we have 18 minus 8 over 5. 10 over 5 is 2. So a is 4 and b is 2. So to find the answer, ft, we need to find the inverse Laplace of a over s plus 2 and inverse Laplace of b just now is 2 over s minus 3. And this one is 4e minus 2t. This one is 2e 3t. So check with the answer from just now. It's the same, just in a different order. Okay. You can, if you want, you can rearrange it. Okay. So what is new here? Not really anything new. It's more for you to practice just now. Because this is still first order derivative, so it's quite simple. Let's go to the second order. Okay. In example 3, the question given is f prime prime t minus 3 f prime t plus 2ft equals to 2e3t. Even f0 is 5 and f prime 0 is 7. Okay, when this is not 0, usually there's going to be a bit more calculation now. If it's 0, then your work would be easier. Okay, so same as before. First, we'll start using calculus. So if you remember, when you are trying to solve a second order differential equation, you need to find YCF and then YPI. Okay, so first we will find YCF. To find YCF, we set the left hand side to become a quadratic equation. Right, remember? And then you can factorize this. M1 is 1, and 2 is 2. So your YCF is equals to AEM1T and BE2T. And next we find the YPI. So if you remember, you need to check the PI table to know what is the YPI. So your YPI, according to what is on the right hand side, which is E3T, 2E3T, our YPI is CE3T. That means our F prime T will be 3CE3T. F prime prime T is 9CE3T. So you put this into the original equation, which is this one. So into here, you will have 9CE3T plus 3CE3T plus, wait, I forgot this one. 9 there's 3 and 2. 9CE3T minus 3CE3T plus 2CE3T is equals to 2E3T. So you multiply all of this. To E3T. So this one cancels out. 2CE3T is equals to 2E3T, which means C is equals to 1. Okay, so now that C is equals to 1, you know that YPI is equals to E3T, because C is 1 from here. Okay, so now you have your YCF, your YPI. So your total Y is YCF plus YPI. Okay, so that's equal to AET plus BE2T plus E3T, right? So now you have this, but you need you have the given F0 is 5, right? F0 is 5, F prime 0 is 7. We can find A and B. So first, we already know what Y is. So now let's, sorry, you know, I mean, this is Y is FT lah, kan? So now that you know what FT is, so to find F prime T, you just have to differentiate this equation, this equation here, which will give you AET plus 2BE2T plus 3E3T. Okay. So now you use the information given here to find what is A and B. So in f0, f0 is 5, equals to a e to the power 0 is 1, plus b e to the power 0 is 1, plus e to the power 0 is 1. So a plus b equals to 4. Then we can set a is equals to 4 minus b. That is from this first equation. Now we use this second equation. Given that f prime 0 is 7, is equals to a to the power of e to the power 0 is 1, plus 2b 1, plus 3 1. So you get a plus 2b equals to 4. So you put 3 into 4, and you have 4 minus b plus 2b is equals to 4, and b is equals to 0. If b is equals to 0, a is equals to 4 minus b, which is 4 equals to 4 minus 0, which is 4. Okay, so look back at this equation here, your ft. Okay, so now we know that b is 0, we know a is 4, so now we have the new equation of y equals to 4et plus e3t. So that's the final answer using calculus. Okay, so I don't think before this I've shown you how to get the complete answer, because we never had an FO and an F prime O before. But in this case, I can show you the final solution now that we have FO and F prime O. So let's do this now. Same question using Laplace transform. Is it easier or harder? Okay. So using Laplace transform, so you apply Laplace on both sides. Equals to Laplace transform 2e3t. Okay, so you substitute with the values that we already know, which is s squared fs minus sfo. Fo is 5, so this is 5s, and then f prime o is 7 minus should I show you the whole thing? I'll show you. Squared fs minus sfo minus f prime o minus 3 s squared fs minus fo plus 2fs equals to, this one you can do directly, Laplace transform that, you'll get 2 over s minus 3. Okay, and then this one you already know what is fo, so 5s minus 7 minus 3s squared fs minus 3 fo. Fo is 5 plus 2fs equals to 2 over s minus 3. So you can put all of the fs on one side. S squared minus 3s Okay, hold on. This is just 3s. Sorry, so this is not s squared. That's just s. Yeah. So s squared minus 3s plus 2 fs, and then we have minus 5s and minus 7. Oh, don't forget this 15 minus 7 and this is actually plus 15. Yeah? Minus 3 times with minus 5 is plus 15. Minus 5s, and then minus 15 minus 7 is 8. So you get this. Okay. So now you bring everything on the other side. 2 over s minus 3 plus 5s minus 8. So that's equals to 2 over s minus 3 plus 5s minus 8, s minus 3, and you get on that side 5s squared minus 23s plus 26 over s minus 3. And then this one you can factorize further and bring to the other side. You will get fs equals to 5s squared minus 23s plus 26, and that is s minus 1, s minus 2, s minus 3. There you go. Okay. So luckily we can use the set cover-up method here since there is no repetition of roots. Okay, so what I mean by that is if you have s squared like that, you can't use cover-up method. Okay, and if this one is also s squared, any of this has a squared or cube, then you can't use the cover-up method. Okay, so we can use the cover-up method for partial fractions. First, we divide everything according to this. Okay, so a. Find a. We set s equals to 0. So a is 5 to the power of 0, dot 23, 0, 26. So at the bottom we have 0 minus, no, sorry, s is 1. Okay. So we have s minus 1, you cover up. So you have 1 minus 2 and 1 minus 3. So we have 5 minus 23 plus 26 over minus 1 and minus 2. So that's minus 18 plus 26, 8 over 2, which is 4. Okay. Now for B we set s equals to, B is s minus 2. So s equals to 2, 5, 2 squared minus 23, 5 times 2 plus 26 over 2 minus 1 is 1, 2 minus 1 and 2 minus 3. So this will actually give you 0 over minus 0 over 1, which is basically just 0 lah. Okay, so B is 0. So this one is 20 minus 46 is minus 26, plus 26 is 0. So the top part is 0, so it doesn't matter what the bottom is. So for C, set S equals to 3. So C is equals to 5, 3 squared minus 23, 3 plus 26, 3 minus 1, 3 minus 2. You get here 45 minus 46, no, that's 46. That's 69 plus 26 over 2 over 1. 45 minus 69 is negative 24. Negative 24 plus 26 is 2. 2 over 2, which is 1. Okay, so now you can put it back in terms of A, B, and C. A just now was A is 4. So you can say that your yt is the inverse Laplace transform, not y, ft. The inverse Laplace of A is 4 over s minus 1. B 0, so we don't take B anymore. We only have C. C is 1 over s minus 3. And then we have the solution of 4et plus e3t. Okay, so compare this with the answer just now. We got through calculus. 4et plus e3t. 4et plus e3t. 4et plus e3t. Okay, so it's the same. Okay, so it's arguable which one is easier. I think for this one might be easier thanks to Laplace, easier a bit thanks to the cover-up method. If you can't use cover-up method, then it would be longer lah. But then again, this method of using calculus is also not that difficult. Yeah, so but at least now you know how to use both to get the same answer lah in the end. Okay, so it's already 12:40. Okay, what I'll do is I'll give you one question for you to do on your own, and we will discuss this on Thursday. And because you can take it home, I'm going to give you something. It's not so hard. This one, This one is so easy. Hold on. I guess I'll give you this one. Yeah, I'll give you this one. It's quite easy, not so hard. But this is really just for you to practice, yeah. So take home. Exercise 12 f prime t plus 3 f prime t plus 2 ft equals to 4t. Even, this one is easy. F0 is 0, f prime 0 is 0. So use both ways, calculus and Laplace. So I hope you try this. I will also upload the notes after this and the video as well. And any questions about today's lecture? Or about this question, or whichever.
No, doctor.
No, doctor.
Okay, so I hope you try it. I will confirm the date of the test with Dr. Zura. I think it should be quite soon. So make sure you do as much examples as you can. There will definitely be questions like what we've done before. I mean, previously in class we have learned Laplace. So there might be questions where you only do Laplace, and there might also be only questions where you do inverse, but there will definitely be questions like this where you have to do both, where we give you the differential equation and you have to use Laplace transform to solve it. Okay, so in the upcoming test, basically you cannot use calculus, okay, because we are evaluating your understanding of Laplace transform. So in the upcoming test too, you can only use Laplace. So make sure you do a lot of Laplace lah, practice. Okay, and then another thing, the other day somebody asked me about the project. Basically, maybe I didn't make it clear. For the project, you need to prepare the report and also you need to present it. Okay, this is because for this course we aside from your technical knowledge, we also assess and give marks for your presentation and teamwork. So the only way to do that is through group work lah, presentation. So we will have the presentation at the last week of lecture, so week 14, and on that same day you basically you present first and then you submit the report lah on the same day lah. So it used to be you need to send the hard copy, but now I think everything's soft copy lah. Just send me the soft copy of your report and your slides presentation, and then the presentation I think should be 10 minutes at most. Okay, so in the 10 minutes you have to explain the contents of your report lah, basically the problem that you chose, how you solve it, and you compare the answer, kan. So that's your project lah, that's your mini project. And then somebody asked, is it better to have the same question for both or different? So I guess it makes sense for it to be the same, because then you can compare the accuracy or the type of the answer you get from both. Okay, but it is not required lah. Okay, the most important thing for me is this, through this mini project you show that you understand how to use Euler's method and Runge-Kutta fourth order method. That is the main point lah. And then you also display your, not just your understanding, but your ability to explain what you understand. That is also given marks lah. Sometimes we understand, but we don't know how to explain. Like if I ask you how to ride a bike, for instance, you know how to ride a bike, but you don't know how to teach other people how to explain, right? So that is important lah in your report and in your presentation. Not just you know how to do it, but you have to explain also. Okay. Okay, so if any more questions about project or anything, just WhatsApp me. For today we are done. Inshallah we will see each other again on Thursday. So I understand quite a few of not quite a few lah of KE students have been infected by the virus. So I really hope you guys stay home. Only go out when you really have to. Okay, and even then, extra precaution, wear double mask if you can. Okay, because it's going to take, they say, at least DG says it's going to take at least 4 months for it to be like normal again. So that's a long time. Okay, so please be patient and take care of yourself, take care of your family. Okay, so that's all from me. Thanks again. See you on Thursday, inshallah.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, guys.
Thank you, Doctor.